So we're going to talk about whether certain lengths of sides can make a triangle or not. Basically what happens on these first kind of problems is it's saying that, well, if these are the three lengths of a triangle, can you actually make a triangle? So before we actually do these problems, let's say that I have one side of this length and then I have these two lengths as the other sides. If I try to put these together, notice that I can't ever connect them. Even up here, I can't connect it down here. There's no way with that these three sides could make a triangle because one of these needs to be a little bit longer or this needs to be a little bit shorter. Okay, so for the examples, what happens and what we find out is that if you add the sides of a triangle, that they should be greater than the third side. So what you'll do here is you'll add the two smallest sides, and whatever you get should be greater than the third side. Now technically it works for it should work for all the sides, but the rule will work if you just do the two smallest. It'll work for the whole problem. So that way you don't have to add every single one. So looking at number 1, these two are the two smallest sides. So if I add 12 and 9 together, I get 21. 21 is greater than 15. So yes, this one will make a triangle. Number 3, add these two together, because those are the two smallest, you get 19. And we're comparing it to 20. It is not greater. This one does not make a triangle. Number 5. Alright, the two smallest ones here are these two. Okay, when you add that, you get 75. 70 is what you're comparing it to. It is not greater, so that one does not make a triangle. Five and 10 are the two smallest. Add that together. 15 is what you're comparing it to. It's equal. It's not greater. This one does not make a triangle. Lastly, let's look here. These two would be the two smallest. You get 14.2. 14.2 is less than 14.3, which is not good. It has to be greater. So the only one on that whole line right there that worked was that first one because the two smallest sides were greater than the third side. I just realized I made a huge mistake. 75 is actually greater than 70. So this one does make a triangle. I'm sorry for that mistake. The two sides have to be greater, and the ones that are greater are 1 and 5. Okay, the next ones, they're asking you to figure out the range that the numbers could fall in for the third side. So it's saying, well, if 9 and 15 are the lengths of the sides, what could be the length of the third side? And so what you do is you add the numbers. You also subtract the two numbers. And when you do this, that gives you the range. This is the smallest number it could be, and this is the biggest number it could be. So, for example, on number 11, if I take 15 minus 9, you get 6. If I take 15 plus 9, you get 24. So the range, I'm going to write it over here, it would be 6 to 24. And that's one way to write it. You could write it with parentheses, you could write it with some less than or greater than, but I'm okay if you want to write your answer 6 to 24. So any length between 6 and 24 is going to make this work. If the third side was anything between there, it'll work. So let's look at number 12. So I subtract these two numbers. 20 minus 11 is 9. Then I add the two numbers. 20 plus 11 is 31. So anything between 9 and 31 would give us a triangle when I figure out those sides. We'll do one more. 23 minus 14 would be 9. 23 plus 14 would be 37. And again, there's your range. So you add them and you subtract them. Okay, let's skip on down. I don't think we've got to do all of those examples. Some other kind of examples that we want to look at about triangles, and some other interesting thing is that the largest side, I'll write this at the bottom, the largest side is always across from the largest angle. I forgot to write side right here. The largest side is always across from the largest angle. And same thing is true about the smallest. The smallest side is always across from the smallest angle. And vice versa is true as well. The largest angle is always across from the largest side, and the smallest angle is always across from the smallest side. So, on number 19, when it says name the largest and the smallest angle, they have given us sides here. Sides is when they give us the length of the lines. Okay, and so if I want the largest angle, well, this is the side, across the largest side. So that means that the largest angle is across from it. So C is the largest angle because it's across from the side that's the largest. Alright, the smallest number I see is 5. Across from 5 is B. So the smallest will be angle B. Okay, number 20. Again, this side here is the largest. It is across from E. So the largest must be angle E. 5, 4, 3. 3 is smallest. So 3 is across from D. So the smallest must be angle D. Okay, notice that we have some problems here, and it says list the sides in order. So in these problems, they gave us the angles, and they want us to put the sides in order. So looking at the angles, this one is the smallest angle, and because they want sides, I got to think about what's across from it. So across from 47 is this side right here, which is AB. That means AB is the shortest. Okay, then I look, I've got 63 and 70. Well, 63 is next. Go across from 63, you get B and C, so B and C must be next. The last one is the 70. Across from 70 is AC, so AC should be next. So when they say list sides, you're listing 2 letters because 2 letters represent a side. Okay, look at 25. So on 25, 25 is across from DE. DE must be the smallest. 30, across from 30 is DF, so DF must be the smallest. And then across from 125 is EF. Remember, 2 letters represents a side, and then 1 letter will represent an angle in these problems. Alright, 26, in order to do this problem, we have to be able to find that third side. So we're going to add 65 and 40 together, and then you're going to subtract that from 180 like you did last week. So 65 and 40 is 105, and if you subtract 180 from 105, you'll get 75 for that other triangle, or the other angle. So in order to finish this, we do have to find all the sides and all the angles. So now I know that 40 is the smallest, so 40 goes across from AB. Then we have 65. 65 is across from BC, and then 75 is across from AC.